So I wrote out the first few because just from listening to you and walking around, it seemed like everyone had gotten to 1, 2, and 3. So I'm just going to verbally talk about them real quick. Number 1, and I don't know if some of you heard me saying this because you were all doing your own thing. Don't worry and don't spend time trying to figure out which one of these is the upper and which one is the lower. It's a waste of time. Just pick one way, do one of them minus the other one, and go with it. If you guessed wrong, what will happen? You will just absolute value your answer. So don't worry about it. Just do the problem. If you did it the other way around, you would get a negative 21 and you would go, oh, the answer is 21. Cool? Yeah. All right. This one, write but do not evaluate, my favorite words. Integral for this area. So you would go from A to D. Do you see those there? And then it's upper minus lower. So g of x minus f of x dx. The only thing that I can foresee getting you guys on that one is the wrong choices, because there's going to be 4 of them and 3 of them are going to be wrong. Okay, so just try to stay focused and ignore all the static. We did all the free response before lunch, so these are all multiple choice. Yep. That was a valid question. All right, so let R be the region bounded by square root of x. And when you draw a quick sketch for these multiple choice ones, that's what it is, a quick sketch. Don't spend a lot of time on that, okay? Square root of x looks like this. Vertical line, x equals 7. Boom, there's your shape. All right. You guys all right? Now, you're going to do this both ways. So for a dx problem, it would be integral 0 to 7 square root of x dx. If you go to rearrange it the other way, you have to square both sides. You would get y squared. It's right graph minus left graph. And if putting the r and the l helps you, right minus left, it's 7 minus square, or not square root, y squared. Look at your boundaries. It's from here to here. It's from 0 to whatever this number is, which would just be square root of 7. Are you seeing where I'm getting that? Like, this is the graph of square root. You just plug in 7, that's square root of 7, whatever that is. All right. Again, that'll be a Roman numeral choice question. And you'll pick the ones that work. I set this one up. We'll work it out together. They pretty much handed you this one. These are your boundaries, 4 to 8. And it would be right minus left. And they went ahead and told you the right one is the 3y minus 8. And the left one, I wrote mine as 1/4 y squared. I suggest doing that. But they handed you the setup. That was kind of nice. Now we just got to do the actual math. All right. So what's your antiderivative? We're going to have to battle through this one. Antiderivative. You get 3/2 y squared minus 8y minus, now you would want it to be 1/3 y cubed, but there's a 1/4 there. So 1/12 y cubed, such that 4 to 8. So we're going to do upper minus lower. Did you guys get through this one? Or at least to there. All right. So let's plug in 8. 8 squared is 64. I would divide by 2. What is 64 divided by 2 going to give you? It's 32 times 3 is 96. Minus, all right, 8 times 8, 64. Minus, all right. Does anyone know 8 cubed? It's 8 times 8 times 8. It is 512. If you didn't know, you could do 64 times 8 off to the side, but that will be 512 twelfths. Hold on, just trust the process. Let's see what we get. Now we're going to plug in 4. 4 squared. 16 divided by 2 is 8 times 3, 24. Minus 8 times 4 is 32. Minus, all right, 4 cubed. 4 cubed is 64 twelfths. Now, here is my suggestion, and you can take or leave it. But what I do is I just recopy the first part and distribute the negative sign, because oftentimes you can kind of combine some stuff together. So I'm just going to distribute the negative through here. Did I write that correctly? Yes. Oh, wow, that was fast. So I just distribute the negative sign and kind of see where that leads me. So let's group together all the whole numbers. You really have to battle through this one to get to the answer. All right, 96 minus 64 is going to be 32. All right, 32 minus 24. 8, and then 8 plus 32, 40. Good, we made it. Go us. All right, and then you got negative 512 plus 64. It's going to be, you know, something twelfths. Oh gosh, what is that going to be? Is that a 512 minus 64? Or I don't want to do it wrong in my head. 512 minus 64. Sometimes you have to do this. 12 minus 4 is 8. Is it 448? Good, there we go. Sometimes you have to do that. There's nothing wrong with that. Those are your thoughts. I had to do that. Some people think I have a calculator inside my brain just because I teach calculus. It's not true. I still have to work stuff out. All right, and then we're going to reduce that. So those will both divide by 4, I believe. So that would be 112 thirds. Now, I went back and checked. They leave the answer like that. It doesn't combine for a common denominator. So for the one that's like that on the test, they leave it as a whole number and then plus or minus whatever that fraction is. That was hard, but we made it. We survived. All right, now this one's calculator. You all got your calculator? All right, if k is in between 0 and pi over 2, and the area under the curve for sine of x, so your wave, from k to pi over 2. Now, hold on. I would just stop reading right there. Because I would be like, from k to pi over 2. That tells me integral. So let's just go ahead and set it up. It's going to be integral from k to pi over 2 of what? Sine of x dx. Good. Equals, and then I would go and keep reading. Like, you get to a point where you're like, okay, that's enough information. I can't onboard anything else. Let's just see what we got so far. Equals 0.3. Now you have to do the antiderivative. What's your antiderivative of sine? Be really careful. Good. Negative cosine such that k to pi over 2, whatever k is. Isn't k is what we're looking for? Yeah. K is what you're looking for. And then fundamental theorem of calculus. It's upper minus lower. Keep calm and know the unit circle. Cosine of pi over 2. Where is pi over 2 on the circle? That's up. Cosine is the x part of the point. 0 times a negative is 0. All right, now when you plug in k, you just get negative cosine k, which looks really weird, but it's the way it is. All right, now we're ready to pick up the calculator. These negatives would cancel, so it's positive cosine of k equals 0.3. And actually, I'll write that out. It's cosine k equals 0.3. How would you get k? This is where we're going to use the calculator. How do you do invert? And well said with the vocabulary. What you said will work too. Just more button pushing, so it takes longer, but it will work. Second cosine of 0.3. I actually don't mind that problem. I don't think that was too terrible. The one before that was sort of awful, but I don't mind that one. Did you get 1.266? Yeah, perfect. All right. I'm going to attempt to do them all. Whatever we don't get to, I'll take a picture of at the end. All right. Oh, this is calculator. That's nice. What is the area enclosed by those graphs? Again, I would not bother trying to figure out which one is upper and which one is lower. Just absolute value it. All right. So we're going to do absolute value of, I'm going to do this one minus this one. It won't make a difference. And don't waste your time trying to figure it out. I get that those x's will combine. You can do that if you want when you go type it in the calculator. I do need the boundaries though. So how could I get those? Bearing in mind you do get a calculator. Put them in y equals, graph them. Yep, type them in here and we'll find our intersections. So we got x to the third. Or here, I'm not going to read it to you. Just go type it. Put 1 in y1, 1 in y2. Start with zoom 6. That's always just a good rule of thumb. Ooh, and this one's actually a little tricky. Do you see what I have up here? So your first one, whoever said 0, you're correct. Your lower boundary is 0. Your upper boundary is not this one. Do you see how it's going to be like over there? Okay, so everyone hit window. I need to raise the ceiling. Which dimension in here will raise the upper? Good. So instead of 10, I'm gonna make it 20. That's kind of a thing you just need to fiddle with until you get it right.
Wait, so how do we know it's not, how do we know we don't do that intersection?
This one? Just because like when you look at that, you can tell that they're gonna intersect again. Like they're gonna cross paths again.
So for rule of thumb, we should do the last time it intersects?
Yes.
And then the first time it intersects?
Yes, exactly.
Okay.
The first time and the last time. All right, so second calculate, second trace, whatever you want to say, intersect, first curve, second curve. Just make sure you move the cursor over. Anyone want to estimate? You want to guess? Is it a whole number? Oh, it's not 18 though. It's 6. Yeah, that is a really common thing. And I would actually be willing to bet money that one of the wrong choices will use the 18. So just be really, really careful. So it is 6, 0 to 6. And then everybody go type that in. You'll get your answer. Or actually, you know what? For the sake of time, could you type that? I'll put the answer on when I take a picture of this. I'll go back and put it on there, okay? Number 7. We're just going to move forward because I want to try and at least set them all up. The base of a solid is region in the first quadrant. We've got x cubed and from 0 to 2. So just for a brief sketch, here's your x cubed graph. Here's 2. It's going to look like this. We'll have a visual. How long did that take me? Like 3 seconds. You don't want to spend a lot of time on that. It's just to have a visual, all right? Cross sections are perpendicular to, good, that means it's dx and semicircle. I saw you guys drawing semicircles, which makes me really happy, and mine is super wonky, so I'm going to fix that. So the base of your shape is going to be upper graph minus lower graph, which in this case will just be x cubed minus 0, all right? Now we're ready to set it up. Boundaries will be what? 0 to 2? How do you get the area of a semicircle? Good. 1/2 pi r squared. I just wrote it blank. R isn't x cubed. It's 1/2 x cubed, or you can write x cubed over 2 because that's the diameter. You want half of that. Again, I would bet lots of money that one of the wrong answer choices will just leave that 1/2 out because it's a really common thing. I even did it in front of you guys the other day. Like I messed it up and then I caught it, but you know, be careful. This is non-calculator, so we're going to have to work it out. Watch me point to this. What is 2 squared going to give you? 4 times 2 is 8. So I'm going to make that a 1/8 pi. And then inside of here, x cubed squared is x to the 6th. Very good. Now do the calculus. What's your antiderivative of x to the 6th? Oh, did you guys get to this one? Seems like you guys are... Okay, then I'll speed it up. All right, 2 to the 7th. Count on your fingers. Watch me do this. 2, 4, 8, 32, 128. See how I did that? Just use your fingers, all right? So it's 1/8 pi, 128 over 7. And you would just multiply 8 times 7 and get 56. Oh, wait, actually that reduces though. Those will both divide by 4, I think, right? Those will both divide by 4 or 8. Will they both divide by 8? What is that going to be? 16 pi over 7? Did I do that right in my head?
Yeah.
I did? Okay, cool. I'm checking it in the calculator. Did you check it in the calculator? Okay. Just to make sure I didn't mess it up in my head. All right, oh, this one we get a calculator for. Let R be the region in the first quadrant bounded by, let's just do a really quick sketch. What does x squared look like? Parabola, that's going to look like that. 2x is a line. It's going to look like that. Like a little banana that's been cut in half or something. Again, that took 3 seconds. That shouldn't take longer than that, just to give you a visual. Cross sections are perpendicular to womp womp. So what I would do, as soon as I realize it's going to be dy, and it's a square, so that's good, I would immediately go and rearrange these. So get them x equals instead of y equals. What's the first one going to be? Yeah, square. Ooh, it is the positive square root. Do you see that? Because it's the right side of it. All right. Square root of y. And then the other one y over 2 or 1/2 y, whatever is your preference. So for your square, the base of it is right graph minus left graph, bless you. So which one is the right one? The parabola, so that's square root of y minus, yeah, y over 2 or 1/2 y. You guys like y over 2, I'll put it that way. A bunch of you have said that at this point, so I'll go with, you guys are fancy. All right, now we're ready to set it up. What are your boundaries gonna be? Oh, I guess I didn't really label my picture. The lower one's gonna be 0. Where would these intersect? Yeah, this would be 2, but good. Your y value is gonna be 4. They intersect at 2, 4, but we want the y value. And then in there, you want to put the area of your square. So that would be what? That squared. I love how you say it because that's how I say it in my brain too. It's that squared. I will come back and type that in my calculator and put the answer. I want you to do that and check it. Okay. To get your decimal answer. I'm just trying to keep things going here. Number 9. Base of a solid, region in the first quadrant, bounded by. This is y equals mx plus b, back from algebra 1 land. All right, it's just written the other way. Your y-intercept is 4, 2, 3, 4, and your slope is negative 4/3. So down 4 over 3. Do you remember y equals mx plus b? Algebra 1 class, a million years ago for you guys. All right, and then, oh, is that it? Just that in the first quadrant. Okay, easy peasy. Perpendicular to, oh, dang, all right, y-axis. So what do we have to do? You rearrange, get x by itself. All right, so what would you do first? Good, so y minus 4 equals negative 4/3 x. To cancel out a negative 4/3, you're gonna multiply by negative 3/4. I'm not gonna bother like distributing or messing with that because it's calculator. I get a calculator on this one, so I would just leave it like that. All right, we have rectangles. The base of your rectangle is right graph minus left graph. Now the left graph just is the axis, so that'll be 0. Your right graph is that. Yeah, that stuff. I want your brain to just go that stuff, like what it is. You're just recopying it. All right, now we're ready to set it up. What are your boundaries? 0 to 4. Do you see y values here? All right, 0 to 4. Inside of there, you want the area of a rectangle. That would be base times height. We have the base right there. The height is 3 times that. So the most succinct way to put it would be 3 and then what? All of that squared. Good. Again, I will come back and type that in the calculator and put the decimal answer on there for you guys to check. For the sake of time, I'm going to keep going. I don't know if I can do them all in 7 minutes. Why don't you guys pick the ones that scared you most? You had a chance to look through all of it. I can't do them all. I'm sorry. I tried. 11. We want to take the region bounded by the graphs of y equals x. What would that look like? Just y equals x. Yeah, just right through the origin. Horizontal line y equals 4. So that would be like this. And the y-axis. All right, so this is our shape. I'm going to erase all the tails outside of that. Again, I didn't labor over that. It's just to get a quick visual. All right, and we're going to spin that revolution around what? Okay, so first let's decide if it's dx or dy. If we're going to spin around y equals 4, good, it's like you just took the x-axis and scooched it up a little bit. So your ghost shape would look like this. Can you envision what that would look like 3-dimensionally? Yeah, like, or a cone. Do you know what I'm saying? Or like a teepee that you can't go inside of because it's solid the entire way through. All right, so it's going to be pi r squared. There's not a hole in the middle. What are your boundaries? 0 to 4. And then inside of there, it's upper graph minus lower graph. So watch me point to it. Which one's the upper one? 4, good, minus the lower one, x. I'm not gonna work this the whole way out, but it is non-calculator. So you would have to multiply 4 minus x times 4 minus x. Remember, just imagine it twice. What would that give you? Like, it would look like this. Are you guys following me? So 16 minus 8x plus x squared. And then you would do your antiderivative. So 16x minus, what is that, 4x squared plus 1/3 x cubed. Again, I'll come back and write that out with plug in the 4 in. What happened?
We did a different way, we got it.
Let me see. Yours looks like mine.
No, but we just, yeah. We did a chain rule.
So it's an antiderivative, not a derivative. So you don't want to do a chain rule. What you can do is a U substitution. That's another way you can do that. Hey, can I bring that up for everybody? If you didn't want to multiply this out, you could do a U substitution. You would let U equal 4 minus x. Do you see what I'm saying there? That's another option. I don't have well, I like this way better to avoid doing a U substitution, but you could do this instead if you want to. It's another option, but not that, I'm sorry. But your thought process was in the right place. I think this is what you were trying to do, but that's, okay, I can do like 2 more. Pick another one. 12. All right, we've got first quadrant region bounded by, oh, what does e to the x look like? It's my favorite graph. Swoop. There you go. It's the best one. The vertical line ln5. All right, I don't know exactly what that is, but ln5. And we're going to spin that around the x-axis. So that would look something like this. That would look like a tree stump. Do you see what I'm saying there? Because it's round. All right, dx or dy? Dx. So it's pi r squared dx. Boundaries would be what? Yep, 0 to ln5. And then inside of there is e to the x. So here's how I would rewrite this one. I would rewrite it as e to the 2x. Remembering your exponent rules, do you see how I did that? Now this one's also a u substitution. I'm going to kind of talk you through it so you don't have to write the whole thing out. You would let u equal 2x. What would your adjustment number be since it's a 2x? 1/2. Do you guys remember u substitution? We did a whole unit on. So like if there was a 7 there, what would you need to put out front? A 1/7. Good. Okay. So I'm not going to write out u equals and all that stuff. I'm just going to stick a 1/2 in front of the thing. All right. So 1/2 pi. What's your antiderivative of e? E. So it's e to the 2x, or yeah, e to the 2x such that 0 to ln5. I just slapped a 1/2 in front of the thing is all that I did. You can write out u equals and do the whole thing if you want, but I'm trying to save you time because the exam's timed, all right? So now we're going to do upper minus lower. That would give you 1/2 pi, or I'm going to write that as pi over 2. You guys are fancy, so you can handle it. Now, if you plug in ln of 5 here, do you see how it would be 2 ln 5? I'm going to write it as ln 25. Where did I get that? Perfect. 5 squared. All right. Now, if you plug in 0, what's e to the 0? Anything to the 0. 1 times 1/2 pi is just 1/2 pi. And then last step, what happens to e and ln? They cancel. So you have 25 pi over 2. Here, I'll write it and show you what it looks like. 25 pi over 2 minus 1 pi over 2. 24 pi over 2, which is 12 pi.